Hello and welcome back to another LeetCode video. This is LeetCode 3423, maximum difference between adjacent elements in a circular array. It's an easy problem, and if you've seen any of the other videos, you know that I'm using these problems to practice the interview process. And easy problems are a prime candidate for those because typically they are so easy that you don't have to waste a lot of mental cycles on trying to solve the problem, and you can focus more on your communications, your problem-solving approach, your explanation, coming up with a solution before writing code, and giving runtime and space complexity analysis before as well. So let's dive into this, and yeah, let's see what we are dealing with here. So we're given a circular array nums, and we should find the maximum absolute difference between adjacent elements. Note, in a circular array, the first and the last element are adjacent, right? And so I would ask the interviewer now, okay, what are the constraints on nums? And I would ask specific questions, not just like what are the constraints, but ask, so nums is an array, and does it only contain integer numbers? Are there only positive numbers, also negative numbers? Maybe floating point numbers? Is it guaranteed that it only contains numbers? Is there a range of values in nums? What is the minimum and what's the maximum length of nums? And typically there's only a minimum one. And can nums be empty? Can it be a none reference or nil reference, right? Those kind of things. Are the numbers maybe in sorted order, you know, which could be interesting to explore. So you want to ask all of these questions, even if you think you already know the solution, because if you find some interesting property in them, you know, you could be able to exploit that property to find another implementation solution, maybe even a more efficient one. So ask more questions than you think you need, and just to make really clear what are the inputs, and also ask what the output should be. And here you can see an integer should be given, and we should find the maximum absolute difference between the elements. That means we don't have to return the index or anything. We really just have to return the absolute difference, which is a positive number, right? Cool. So yeah. And the answer to our questions regarding constraints is we have at least two elements in the array, and we have positive and negative numbers. We can probably assume that those are integer numbers, looking at this range here. Okay, so how can we approach this? Well, I guess a naive approach would be to, well, actually, I should look at the examples first. And so here we have an input array with three numbers, 1, 2, and 4. And the absolute maximum difference is 3. Let's see why. So we have 1, 3, and 4. Right, so what are the differences? And if we have 1, 3, 4, it's okay if I write 1 here at the end, because it's looping around, right? So 4 and 1 are neighbors, right? So it's okay to visualize it like that. Now, what is the absolute difference between 1 and 2? It's 2. Between 2 and 4, it's 2. Sorry, between 1 and 2, it's 1. Between 2 and 4, it's 2. Between 4 and 1, it's -3, but we take the absolute value, so it's +3. That's why we return 3 in that case. Cool. Now let's take the next example for our little workbench here. And I'm just going to write the -5 of the first element at the end. A little easier for us to reason about this. So the maximum difference between -5 and -10 is going to be 5. Then again, we have a 10 and a 5, so it's 5. Then it's 0 between the first and the last element. So here the result would be 5. Cool. All right, so I think we can get away with a linear time and constant space solution where we just iterate over the array. And we have to take into account that we have to loop. Well, I suppose we have to use an index to iterate over the array from I to the length of the array nums, but +1. And then we want to take I modulo length of the nums to be able to access the first element when we reach the end of the element. That was probably a little bit convoluted, but what we'll do is we'll loop over the entire array, compute all the differences, and remember the absolute difference. And then we also make sure that we compute the difference between the first and the last element, which always exists since length of nums is at least 2. Right, so let me just write that down. So it's compute of n time and of one space solution. And yeah, and now I'll just implement the loop. And in an interview, I would ask the interviewer if that's okay and if I should go forward and implement it. Always important to get your interviewers buy-in. Otherwise, you might be going off a tangent and run into an issue that you don't want to run into. So for I in range, and I'm now choosing an index so that I can iterate over the indices. I'm just going to add a +1 here. And then at every step, I'm just going to compute the difference between neighboring elements. So nums I. And at nums, well, I +1. However, I +1 will reach the length of the array. So this will be an index out of bounds exception. So I have to do a modulo length of nums here. And some people like to pull out the length of the input, put that into a variable. So maybe that's a little bit easier to read. I don't know. And yeah. And now we have to take the absolute value of the difference of adjacent elements. And we have to remember the result value. Now, we know that we're going to take the absolute value, and we know that we have at least 2 elements. So the smallest difference can actually be 0. So it's fine that we initialize our result with 0. Now, if it wasn't the absolute value, we would probably have to initialize it with something else like -infinity or so. We're going to return the result, and then we're going to say result is the maximum between the diff and the result. I think that would be everything that we need. So let's run the test cases. Index out of range. So something happened here. Modulo 10. I thought I was guarding against it. Oh, I don't need the +1 here because I already have my +1 here. Right. That was a mistake because I was going too fast. Cool. So now the test cases pass. We get this correct result here. Let's submit the solution to see if it passes all of the test cases. And it does. And that concludes this little exercise.